Hello! In this video I want to implement the bubble sort in Haskell. Actually, I want to practice a little bit in imperative style programming in Haskell. As you know, Haskell is a pure language, but on top of this, using monads, we can implement the imperative style of programming. Okay, we use monads because monads allow to us to encode sequential evaluation. Okay, let's start from the idea of the bubble sort. Okay, it's very simple. We have some array and we do the iteration of this array. We go from the start of this array to the end of this array and we compare nearest elements, and if they are in wrong order, we exchange them. Okay, we do the first iteration and the most biggest element go to the last position, and actually now we a small array by one element from 0 to n-2 position. Okay, so the last element is in the right position now, and so we do these iterations again and again until our we have not empty array. So, and of course we can stop with the during the whole iteration. We don't do any exchange. Okay. Okay, and which statement they need to implement this? If we look from imperative style point of view, we need to until statement. So we repeat our iteration at least one time, and we need to repeat this iteration until some condition hold. Actually, this is our condition that we have go through all the elements of the array, or if we don't do any exchange during the iteration. And actually Haskell has this type of statement. Actually, Haskell has no statements. It has this kind of monadic function. And it now I will show it. Okay, but the problem is that it is not in the standard model, so I need to install some models. But I think we can easily re-implement this function now. And let's start from its type signature. I think what's the type signature of this function? Okay, we will call this function until. And what is the type signature? Okay, we need some monad for it. Monad m. The next thing they need to provide some monadic action. And also we need to provide some monadic action which contains some Boolean value. And as a result, we have monadic action, and actually we don't interested in it result. So we will repeatedly repeat this action until this condition holds. Okay, and in the end they have this action which has no result at all. Of course it has some result, but it is side affected, and we express this with this monad. So let's start implementation. We have this function, the need action, which represent the iteration process, and the need the predicate, which represent our stop condition. Now we need to write body, and we know that type of this expression is this type, and we can define it using do notation, of course. We need to use this do, and what we do at first, because we have this action A here, we need to perform this action at first. Okay, and then we have this predicate, not a predicate, actually monad which embed the bool value. We can extract this bool value, I think like this. And now, after we extract the boolean value, we need to decide if we continue our iteration process or we stop. Okay, and I can express it like this: if our b, then we repeat our until process with the same parameters. Okay, otherwise we return the monad with empty tuple, okay, with the unit type. Okay, I try to compile this code, and as you can see, Haskell type me this error, ambiguous occurrences until. So I think I need to change name a little bit. Actually, this means that until already exist. Yes, there exists this type of function. Let's rename it like, I think, until underscore. Action, predicate, and until. Okay, model compiled. Okay, and now let's check our until function, and let's use some helper for this. There, I want to ensure that this function can produce for me actions until some condition holds, and then this condition break, then we need to stop. Okay. Okay, the first section. Actually, how I want to check this? I want to print some string on the screen until user put stop. Okay, so I print some string on the screen and ask for user for input, and if user give me stop, I want to stop, and otherwise in the string I want to continue. Okay, how can the represent these actions. So with the print, this is very obvious, but with the predicate action, I will call it PA action, and it has type of IO bool, and implementation is we need to at first read line, and then we need to pass this line to some lambda function which has this line, and if this line is equal to exit, then we need to return false. Otherwise, we need to return true. I think something like this. Okay. Yes. I think yes. Let's try. So I will call this action. As you see, it waits for input. I will input 1, 2, 3. We have a error. And why we have this error? Well, we have this error because I need to use braces then. Okay. As you can see, if I use braces, it works as expected. So it returns me the true or false, depends on the string which I input. And now let's try to check my until function. Until function. We need to provide our action for it, and this action will be print go, I think. And the next thing we need to provide is our predicate function, I think. And let's look. Okay, errors. Of course, errors because I run not my function. My function is until underscore go. As you can see, the iteration, the first iteration, the first, how to say this? The first try of iteration was successfully done, and Haskell asks for me a string, and I will input some empty string, and it proceeds the iteration. If I need input some another string, it continues on my iteration. And if I input stop, okay, it stop. So our until helper works as expected. So now I can use it to implement bubble sort. And let's dive into this implementation. I will call it bubble sort. Bubble sort. Okay, what they have on input? On input, we have some list of A's which implement the order type class, and on output I want to produce the sorted list of A's. Okay. Of course, I need to use some monad here, and I think better to use stmonad because they do some processing in our memory, and the stmonad is implemented actually for this type of actions. And they need to import model at first for stmonad, import control from monad st. Okay, and now we need to say that our result inside this st monad. Okay, I think like this. Okay, Haskell has some types which represent the mutable array, something like a st array, which is like a ordinary program, ordinary array which represented in imperative languages. But I want to use just STref to represent array, and I want to use STref, and I want to use a list of STrefs. So if I have a list of STrefs, I can look at them like an array. But the problem is that I think list will be very slow for access because it has not a constant time to access the reference. Actually, I need to think here a little bit. Yes, I think list will be very slow for accessing the STrefs, and we need something that has a constant time to access by index. And Haskell has this type. It's called it's like a map, but it's a special map for when where the keys are ints. It called it has it represents this type represented in model data.intMap. So it's like an ordinary map, but the keys are ints, and because it has some these constraints on keys, it can access the keys by the constant time. So it's somehow like we can look at this somehow like an array. Okay, let's import this module. Import data int map strict. Now let's go to implementation. We can use two notation because in the context of monad. And of course we have some list. What is the first step? The first step, I want to transfer this this list. I want to transfer this list into the map, into the int map of STref references. So to build the map, they have this function. I think we have from list function. You can see type signature here. This function take a list of keys and a list of pairs of key and some element and produce the int map. Okay. So I need to construct the list of these STrefs. Okay, let's take elements from our list. and build another list. Okay, we take element, and now we need to create STreference. New STref. Of type. We need to provide a value here. Some value A of type A. And of course, this is our element. And next thing, I think I need to enumerate this list of REST references. I think I can do this like this, zip function. And let's name this thing as a underscore. I think it's better to use the list underscore. But no, I think it's better to go another way. The problem is that if I use this, I will have a list which have st-monad, and inside of this monad will be strep. But I need to somehow extract. I need to just a list of strefs. Well, how can I do this? I can do this using map_m function. Let's look at type signature. Map_m. We need to provide the monadic function traversable. So this is our list, and it will produce to me monad with my list. Okay, actually I can use map_m new STref and my list, and then I can extract this and get my list underscore. So actually this will be a list of refs, and on the next step I can modify this list of refs with a zip from 0. So I can build pairs with my list underscore like this. And now I can use this list to build a dict. So let's build some dict which will be built from list of these pairs, and I can use this list underscore, I think, like this. Okay, now actually I prepared all the data needed for my sorting, and from here I can call my until function. So the function which controls the main process of the sort, or the bubble sort. And of course I need to provide some action and some predicate. Okay. Okay. Of course, I need to define this action and these predicates. And what is the last action of my monad definition? Main monad definition, I mean, this is definition. So, when they do our bubble sort, we'll have this D, which contains our references, STreferences to our elements, and we can take all the elements from this D, and they can use map function, and they need to read every STreference, read STreference. So if I this thing will give to us actually this type, because the read STreference, and for every element of this list we will map it into stmonad, and mapm function will wrap inside out this monad out of our traversable list. Okay, last thing, we need to define action and the predicate. Not the predicate, monad and then the boolean inside. Okay, let's start with our action. The A is, of course this is the monadic action. So what we do on every step of the iteration. So on every step of iteration we need to go from the 0, from the first element, until the last -1 element, and do the swappings. And of course we need to somehow extract the information of how elements what is the last element to which we need to go in this current iteration A. And let's initialize this name here. I think this will be something like last, and we can create the new STreference. And what is the value? Of course, the start point, we need to go to the length of the list -1. I think like this. And we need to extract this reference. So let's name it as a ref last. So this is a reference to which contain the integer which represent the last position of the iteration to which we need or the element to which we need to go in this current iteration. Okay, and here I think we need to at first read this information. So we can use read STreference with a reference last. And we can extract it like this. Actually, this will be the integer. Okay, and now we need to repeatedly do some process of exchanging with the comparing of the nearest elements for don't hold. We can use for m function for this. Let's look at type signature. Let's import control module at first. Control not. And now we can see the type signature. So I can use my list from 0 to last, and here I need to provide the function which takes the current index on which we want to do the comparison to the nearest element. And here I need to define the function which take this index and provide some action. Actually, here I need to do this weapon logic. So I needed first to read STref reference at position I. Okay, how I can get it? I can get it from this D, and I need to access this D element in by the I position. So moment. Okay, to extract the element from my int map, I have a function find the default. I can use function find the default because I'm sure that for this k I have this element, and for default I can provide some error function. So here we can fold the error no index, and this is not possible situation to, so I expect that this situation is not possible. Okay, the next thing I need to provide my index, and I need to provide D. Okay. I think like this. And this is our current element, so I can extract it. Because I am inside STmonad, I can extract it. Next thing, I need to extract the next element after this. And this is I plus 1 element, of course. So element 1 and element 2. Now, what I need to do next? Now I need to compare these elements. So I can use conditional action here. So when my element 1 is greater than element 2, in this situation we need to swap. Okay. And I can use the notation here to define my swap action. Can it be defined? We need to, I think, use to write STreference so let's do some naming here. Let year 1 reference, so this will be year 1 reference, and this will be year 2 reference. Okay. And they need to we need to swap. So at the year 1 reference we write year 2 element, and at year 2 reference we write year 1 element. Okay. I think like this. And in the end, after they do this, for every index, we need to change. So we need to modify STreference reference last, I think. How we need to modify it? We need to modify it with -1 function. So how can I define -1 function? I think like -1. So I can define -1 function like this. Of course I can see errors, but I will fix them later. I want to write the main logic here as I see it now. Okay. What I miss here? I miss here the fact that I need some flag that show me that I do some swapping. So let's call it is swapped, and of course I created the newest reference, and it has false inside. And here in this action I need to modify it. So I need to write to is swept the false, the true, sorry, the true. And now let's define my predicate at last. Predicate. Okay, how we decided they can stop? We stop if our is swept. Our is swept is at false. Okay, if it is false, when they stop, or if our reference last is equal to 1. Sorry, 2, I think it's equal to 0. So we do all the this means that they do all the iterations. And also, of course, here I need to modify, not modify, right, STref swept false. So at the start of every iteration we it with the false. So I think here we need to read the STref is left. So we need to extract it from our STmod and the next thing we need to extract is our reference. So actually we need to do this. Yes. Okay. And when the stop if our is swept is equal to false, or our last is equal to 0. Then we return false. Otherwise, we return true. and I think here we need to use 1, not 0. And here we need to use -2. But no, here we need to use 0, I think. Okay. Modify STref. Let's add it here. Oh, let's do a little bit of renaming here. I will remind is swept, ref swept. Ref swept. Ref swept. And now, let's try to, you can see, I have some scoping problems. This, you can see these names, and I think we need to basically pass them. Okay, something like this. And also D. And okay, let's define swap function here. Swap. Okay. Pretty much, very much code for bubble sort, I think. But I hope it compiles. Yes, it compiles. Okay, now let's try to run this code. So recompile, and we run this. We run st. So I build my monadic st monad value will be sort. It has this type, and we need to use run st function to actually run our st action and compute the value inside our st monad. So we run this, and we can see that I think we don't do the last iteration, and that's happened because I think I need last -1 here. So if I have the last at 0, I think I need to do last one iteration at the 0 point, from 0 to 0. I need to compare the 0 element and the element with the index 1. Okay, and if comparison is broken, I need to swap them. So let's try to reload, and we run, and we can see that we get the sorted array. So our bubble sort work as expected. Okay, let's try to some other types of arrays. Okay, you can see that we get the sorted array. And I think that's all for today. This was bubble sort with STref. Thanks for watching. Push like button, push subscribe button, write comments, and see you in the next video. Bye bye.